I want to take some time and go through an example to illustrate the difference between distance and displacement. So let's think about that familiar particle problem, that a particle starts at the origin and moves along the x-axis, such that its velocity is given by v of t is equal to t squared minus t minus 12 for t being on the interval from 0 to 5 seconds. So if we were to graph this relationship for velocity, it's going to be a parabola. T squared minus t minus 12, that factors into t minus 4 times t plus 3 equals 0. So that means that we have 0 at positive 4 as well as negative 3. The y-intercept happens at negative 12, so we're going to have a parabola that looks like this. So there's a little graph of the velocity function. Question I want to know is, when will it stop? Well, a particle is going to stop when its velocity is 0. That's going to happen at 4. So after 4 seconds. So this particle is going to start at the origin, and then it's going to, because the velocity on this interval is negative, it's going to move to the left for a long time, actually for 4 seconds. Then it's going to stop. And after that, its velocity is going to become positive, so it's going to start moving to the right. So let's find the accumulation function for this situation. So the accumulation function is going to be the integral from 0 to x of the velocity function. Alright, so that's going to be the integral of t squared minus t minus 12 dt. And when we integrate that, we'll have 1/3 t cubed minus 1/2 t squared minus 12t evaluated from 0 to x. So that'll just give us x cubed over 3 minus x squared over 2 minus 12x. Okay. We can use that to figure out where the function is after 3 seconds and 4 seconds and 5 seconds. So if we want to find out where the function is, we're just going to find d of 3. So 3 squared over 3 minus 3 squared over 2 minus 12 times 3. And we should get negative 31.5. So it's going to be at negative 31.5 on the x-axis, so 31.5 units to the left of the origin. At 4 seconds, that was when it stopped, we'll have 4 cubed over 3 minus 4 squared over 2 minus 4 times 12, 48. And that'll leave us with negative 34 and 2/3. And after 5 seconds, d of 5 is going to be 5 cubed over 3 minus 5 squared over 2 minus 12 times 5. And that'll be negative 30 and 5/6. So when we're thinking about what happens, this particle is going to start at the origin. So it's going to start here at 0. And then over the next 4 seconds, it's going to always be moving to the left. And we saw d of 4 was negative 34.6, repeating that negative 34 and 2/3. So that's how far it moves to the left. 34 and 2/3 units to the left. That's where it stops. Then it turns around and moves to the right for 1 more second until it finishes at d of 5, the negative 30.83 repeating. That's ending at negative 30 and 5/6. Well, how far did it travel there? What was that distance? that it moved to the right? Well, if we just find the difference between those two, we see that it moved 3.83 or 3 and 5/6 units to the right. So how far did this thing travel overall? Right? When we found d of 5, what we found was that difference right here, that it was negative 30 and 5/8. That was d of 5. Right? That integral from 0 to 5, that net change in position was that much. But that's not how far the particle traveled. How far did it travel? Well, it traveled some to the left, 34 2/3. And then it stopped and turned around and went some to the right. So it went 3 and 5/6 units to the right. So all in all, it traveled 38.5 units altogether. Right? Not to the right, not to the left. Right? Some of it was to the right and some of it was to the left. Now there's a couple things that I want you to notice. First of all, we've been using the integral of velocity to talk about distance, to think of it as distance. But when we found that integral from 0 to 5, we didn't actually find distance. I mean, it is a distance, but what we actually found was a net change. We found the net change in position. This is what we call displacement. Like how far was it displaced from where it started to where it finished. If we want to find that total distance traveled, that total distance, remember that we were going to the left from 0 to 4. That was our left distance. And when we went from 4 to 5, that was our right distance. The thing is, when we find those integrals, the integral from 0 to 4 is going to be a negative number. When we talk about a total distance traveled, we don't want to deal with positives or negatives, in that sense that we're talking about left or right, because the total distance traveled is the collection of all the distance we went to the left as well as all the distance that we went to the right. So we would only describe that as a positive number. So to find out what that distance to the left was, instead of looking at it as a negative value, we would take the absolute value of it and consider it as a positive amount. Then to that we would add how much we took to the right, that absolute value there. So how we would write this out. Remember, if we went from 0 to 5 of the velocity function, this would give us that displacement, where we ended up compared to where we started. So if we were to just put absolute values around the outside of this, what we do is take that negative 30, that displacement, and just make that a positive value. That's not what we want to do. Instead, we want to take all of those negative velocities, those times that we were moving to the left, and treat them as though we were moving to the right. And then add them to all the times we were actually moving to the right. So we would want to put the absolute value just around the function, not around the entire integral. So the big idea, and in a calculus sense, the difference between displacement and distance is that when we're taking the integral from where we start to wherever we finish of the velocity function, what we're finding is the displacement, the difference between where we began and where we ended. When we want to find out how much we had to travel to get there, that's when we take the integral of the absolute value of velocity.